Hi, in today's video I would like to introduce you a very nice problem of Bulgarian Mathematical Olympiad edition 1984. Here is the following information. Find all positive integers x, y and z. Here is the following equation. We have 5 to the x is multiplied by 7 to the y plus 4 equal 3 to the z. Okay, in fact this is very nice problem involving exponent x, y and z as integers. So the hint that I'm trying to give to this problem, just try to find a trick how to factor these two terms and make it as a two-side equation and make the comparison between those terms. Okay, so the second hint, we are going to use the order notion as we have it in the recall here. So the order of m modulo n is p if m to the r is a congruent to 1 mod n, but m to the s is not congruent to the 1 mod n. For 1 is inferior or equal to s, s is strictly inferior than r. Here is the short term, order of m modulo n equal to p. Okay, so I'm going to explain this one a little bit. I'm going to reduce the error to the smallest value of the exponent in the way to make it as a smallest error to get this condition. This is the facts what we are going to use in this problem while working on this one. Okay, go ahead, pause this video if you would like to give a try to this problem. When you are come back to see the full solution. Okay, let's get into the solution. Now we have this equation. The first step, I'm going to try the obvious cases. Let's try x equal to 1 and y equal to 0. Okay, I'm going to plug x with 1 is multiplied by 7 to the 0 plus 4. This one is given as 5 plus 4, which is 9. 9 is written on this form, 3 to the 2, which is z to the 2. That means we found z also, z equal to 2. So we found the first solution. Try the first cases. You don't have no solutions verifying this equation. Now let's move on to the general case. So when we have x, y, z. Now we have this equation, 5 to the x is multiplied by 7 to the y plus 4 equal 3 to the z. Now I'm going to use the trick in order to factor out this one. So I'm going to write this one as we have 5 to the x is multiplied by 7 to the y plus 4 equals 9 minus 5. 9 minus 5. So I can extract 3 square from this one in order to make it 9. Okay, so I will have 3 squares becomes 9. Okay, I'm going to move over this 9 to the right hand side of this equation, make it as a common factor, and make this 5 and this 5 to the x as a common factor as well. So I will have 5 is multiplied by 5 to the x minus y is multiplied by 7 to the y minus 1 equals 9 is multiplied by 3 to the z minus 2 minus 1. Okay, here's a very nice expression here. Let's call the left hand side of this equation as a red star and the right hand side of this equation as purple star. This is the left hand side of this equation. This is the right hand side of this equation. Okay, if you take a look carefully at this equation, we have the left hand side of this equation is a multiple of 5. Okay, is also the right hand side of this equation is a multiple of 5 because we have equality. Okay, but 9 is not multiple of 5. That means this term 3 to the z minus 2 minus 1 is a multiple of 5. Okay, let's write down that. You will have 3 to the z minus 2 minus 1 is a multiple of 5. Let's use the congruence definition here. So this one that means 3 to the z minus 2 is a congruent to 1 mod 5. Okay, here is the first statement. Now we are going to make the combination between exponent and error, as we saw before. Okay, so to find z minus 2, we are going to use the error notion. Okay, so now we are going to prove these facts. I'm going to find error of 3 mod 5. Okay, we are going to prove equal to 4. So as we know, this fact 3 to 1 is a congruent to 3 mod 5. Okay, it's normal because by bringing this 3 to the left hand side of this equation, it gets 0 here. That's mean 5 divided 0. Okay, so I'm going to multiply both sides by 3. I will get 3 square is a congruent 9 mod 5. 9 mod 5 is 4 number than 5. That's mean I have 4 mod 5. 4 mod 5. Because 5 mod 5 is 0. So get this one. So I'm going to multiply both sides by 3 also. I will get here 3 to the 3 is a congruent to 12 mod 5. 12 mod 5 is the same thing as 2 mod 5. 2 mod 5. Okay, so also I'm going to multiply both sides by 3 also. I will get 3 to the 4th is a congruent. I will get here 2 to the 4. Here I will get 2 is multiplied by 3 is 6. 6 is the same thing as 1 mod 5 because we have one more number than 5. I will get 1 mod 5. Okay, so I have proven this one. So this fact is proven. If you take a look at both expressions are written in the same way. Okay, we have 1 mod 5, 1 mod 5 here. So that's we are going to replace z minus 2 by 4. But remember, an exponent is always a multiple of error. So we are going to express this one. We have z minus 2 equals 4m. What is m? Some natural numbers. Okay, now I found 3 to the 4m is a congruent to 1 mod 5. Okay, I'm going to replace z minus 2 with 4m to see what's giving us this one. Okay, I have 9 is multiplied by 3 to the 4m minus 1. I'm going to factor out this one. Is giving me 9 is multiplied by 3 to the 4th minus 1. I know it's very tricky to factor out this one. I will get 3 to the 4 and minus 1 plus the second term 3 to the 4 is multiplied by m minus 2 and so on and so forth until you get 3 to the 4th plus 1. Okay, so this one, this term, so 3 to the 4th is a 81. 81 minus 1 is a 80. 80 is a multiple of 5. Okay, I can rewrite this one. 9 is multiplied by 5 is multiplied by this box. What I mean with this box, I mean this box, I mean this term. Okay, if you take a look carefully at this expression equals this term 9 is multiplied by 5. Okay, that's mean this term is the same thing as the right hand side of this equation. Okay, that's mean this term is a multiple of 9. Okay, is also the left hand side of this equation is a multiple of 9 because of equality. Okay, but 9 is not multiple of 5. That's mean this term 5 to the x minus 1 is multiplied by 7 to the y minus 1 is a multiple of 9. Okay, so now let's clean up the board and express that in another equation. Okay, as we said before, this expression 5 to the x minus 1 is multiplied by 7 to the y minus 1 is a multiple of 9. Okay, let's transfer this one into the congruence. This one implies, so this one is giving me 5 to the, by using the congruence definition, 5 to the x minus 1 is multiplied by 7 to the y is a congruent to 1 mod 9. Okay, let's express this one into two different statements. I will have 5 to the x minus 1 is a congruent to 1 mod 9, and also I will have 7 to the y is a congruent to 1 mod 9. Okay, now I'm going to find out both expressions. Now we are going to find out both exponent x minus 1 and y by using the order notion. Okay, so let's clean up this board and move on to the next step. I have 5 to the 1 is a congruent to the 5 mod 9. Okay, I'm going to multiply both sides by 5. We'll get 5 square is a congruent. I get here 25. I have the 7 more number because we have 9 is a multiple of 18, so we'll get here 7 mod 9. Okay, so I'm going to multiply again by 5. I will get here 5 cubed is a congruent. 7 is multiplied by 5 here is 35. 27 is a multiple of 9. From 27 to 35 I get 8. That's mean 8 mod 9. Okay, so again I'm going to multiply this one by 5. I will get 5 to the 4th is a congruent. 5 is multiplied by 8 is 40. 36 is a multiple of 9, so I get 4 mod 9. Okay, I'm going to multiply again this one by 5. I will get 5 to the 5 is a congruent. 4 is multiplied by 5 is 20. I know 18 is a multiple of 9. That's mean I get 2 mod 9. Okay, again I'm going to multiply by 5. I will get 5 to the 6 is a congruent. 2 is multiplied by 5 is 10. 10 I have one number more than 9. That's mean 1 mod 9. Okay, now I hit the order. Now I get the order of this one. Is it written the same form as I have here? Okay, so the order equal to 6. That's mean exponent is a multiple of the order. So we'll get here x minus 1 equals 6k. What is a k? Is a natural number, some natural number. Okay, now I'm going to find a y. Okay, I do the same job as we know, since we are working mod 9 is 7 mod 9. I'm going to multiply both sides by 7. I will get here 7 squared is a congruent to 49 mod 9. As we know 45 is a multiple of 9. That means I get 4 number more. I get 4 mod 9. Okay, so by multiplying by 7 on both sides, I will get here 7 to the 3. 4 is multiplied by 7 is 28, is one number more, is 28. Since we know is 27 is a multiple of 9, that's mean I have one number more here. I will get 7 to the 3 is 1, is a congruent to 1 mod 9. Okay, I found the exponent of y equal to 3. That's mean exponent is a multiple of order. So I will get y equals 3L. Okay, what is L? Some natural numbers. Now this one is verified. This one is also verified. I'm going to put this information here. I have 5 is multiplied by 5. I'm going to replace x minus 1 with its value. I found 6k and I found 7y equal to 3l minus 1 is a congruent to 0 mod 9. Is a solution of left hand side of this equation. Okay, we found also 9 is multiplied by 3 to the 4m minus 1 is a congruent to 0 mod 5 is a solution of right hand side of this equation. right hand side of this equation. Okay, if you take a look carefully, the same equation, the left hand side of this equation, we found the solution with mod 9, and the right hand side of this equation we found a solution in terms of mod 5, which is contradiction. Okay, impossible to find same equation with two different modules. The left hand side has mod 9 and the right hand side has mod 5, so this is impossible. So there is no solution. So no solution when we have x, y, z is superior or equal to 3. Okay, so the only solution that I found, so we will have x, y, z is strictly inferior than 3. We found only one solution, x equal to 1 and y equal to 0 and z equal to 2. Okay, I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.